we're going to focus a little bit more on requirements and go into more depth on that aspect of road. So the first thing in defining requirements is if you're dealing with an AI application, I would argue that there are three primary broad uses of AI. It's either making better decisions, it is automating something, and automation doesn't have to be a physical factory line. It could be automating like claims processing, for example, or interaction. And interaction could be with your end client or customer, but it could also be improving your help desk in their ability to get information to help a customer support type human interaction. When we deal with data, there is either data accounting, which is I need to get my invoices ready for billing, or I need to I need to prepare for an audit, something like that, where the data has to be perfect. You're not really making decisions as you are tracking this data for future use or for some sort of regulatory compliance. That is data accounting, which is very different than decision support. If I'm doing data accounting, I need to have perfect data for whatever audit requirement I have. If I'm doing decision support, it might be more efficacious to have a sample of imperfect data that I can make decisions off of faster and quicker, and I don't need that data perfection. That decision right there is going to have implications in the type of data architecture you do, the cost you're going to have in your program, and how much effort you have in the data step. It's important to try and identify testable hypotheses. A lot of projects will find people exploring patterns in data and then jumping to conclusion. Well, if we understand something about statistics, we typically have a risk of mistake that people typically set around 5% of the time. That means that 1 out of 20 interesting patterns is completely anomalous. And you're gonna find spurious correlations, and it's going to lead to mistakes and error if you're just going through patterns. When we are exploring data, or when we're asking people what their gut instincts are, those are equivalent. Those are equivalent processes, and what we're trying to do is we're trying to get the insights that's going to allow us to have ideas that we can test. But you have to have that deliberate pause in the scientific process where you stop and you test the hypothesis. I suggest we use SMART goals. Are the things that we're testing, are they specific? Are they measurable? Are they achievable? Are they realistic? Are they timely? Right? So you can think of SMART goals. Design thinking is a great way to elicit requirements as much as exploratory data analysis. So don't fall victim to, I'm just going to look and see what the data tells me. Ask people too. Malcolm Gladwell has a great book, Blink, and in it he shows some examples where, they do all this analytic process to evaluate whether art is genuine or not, and art dealers in an instant can look at it and say, yeah, that's fake. There are times where human intuition has this implicit, undefined understanding of the context that is, in many cases, more valuable than observed patterns in data. I'm not arguing over one versus the other, but you use both of them to draw your hypotheses and your understanding together. That's where design thinking can really help elicit those requirements. And like I said before, you have to go back and formalize what you think the key levers are and test them. That is a critical step in this road process. It's essentially the way you're guarding against confirmation bias. And the question you should ask at the end of the requirements phase and the end of creating the testable hypotheses are you prepared to be wrong? If you are not prepared to be wrong, you probably are having high levels of bias influencing the process, and you shouldn't be surprised when you're not satisfied by the results of the analytic process, if it's just simply designed to confirm your pre-existing biases. One of the aspects of looking at requirements and domain expertise is the domain expert can really help you break down the system into subsequent parts. This is an example of looking at autonomous vehicles. There's a couple different sources here where when we look at an autonomous vehicle, there's different components that go into that, different sensors that you may or may not want to have in your vehicle. And breaking them down allows you to focus the road on each component separately. You don't want to say, let me just build an awesome autonomous car as the requirement. That's not a very specific requirement. And so what data do you use? What analytic do you use? It's too big of a project. You need to have the domain expert break decompose the problem into the subsequent, smaller parts that you can actually get action against. And then it's up to the boss or the decision maker to decide what they're going to invest in and where they're going to actually invest in AI or use a gut process. Oftentimes, a managerial leader's gut is they've got experience and intuition. It's very wise, and maybe they don't need AI to automate that decision or to offer an insight into something they already know. So by decomposing these requirements, you can actually decide where we're going to invest in AI and where we're not. And that might be a time thing, right? We might invest in AI for these 2 or 3 components now for the biggest bang for our buck. And in year 2 or 3, we're going to then incrementally invest in more areas, right? So that's all part of this requirements and requirements definition. Here's another example, right? So when we look at a typical IT enterprise, you might have different layers in the IT, right? Like here at the bottom, we have facility services. At the top, 3 layers, you have kind of these abstract mission capabilities, architectures, peoples, right? And so by breaking these different layers in, right, or looking at cross-cutting ones like information security management, you can decide where are the greatest opportunities for AI. Where do I want to begin? Where are my biggest problems? What keeps the boss up at night? Where's the biggest areas of risk? Where is the area that is not performing at its best capability today? And by breaking these problems down into smaller areas, you're defining requirements that are more focused and are going to result in success.